Let us examine question 2. A particle of mass 18 kilograms is pulled along a rough horizontal table by a force of 30 newtons with a frictional force of 4 newtons acting against it. Given that the particle is initially at rest, find A. the acceleration of the particle, B. find the distance traveled by the particle in the first 4 seconds, and C. you are required to calculate the magnitude of the normal reaction between the particle and the table. Let us model the question. So here we have the particle resting on the table. The particle has a mass of 18 kilograms. So that's 18 kilograms there. Now, what are the forces acting on the particle? It has been pulled by a horizontal force of 30 newtons. And also the frictional force there is 4 newtons. What are the other forces acting on the particle? Well, we have the weight, which is a force, and weight is mass times gravity. So the mass here is 18 kilograms times gravity, which is G, and that's in newtons. And the other force would be the normal reaction, pushing the particle upwards. So these are all the forces acting on the particle at the moment. So we are required to calculate the acceleration. So we take acceleration to be positive to the right. And that's meter per second square. How do we calculate the acceleration? Well, we know that force is equal to mass times acceleration. So let's resolve in the horizontal direction. So in this case, we have force is equal to mass times acceleration. And in this case, we resolve in the horizontal direction. So the force there would be 30 minus 4, and then we would have the mass, which is 18 kilograms, times the acceleration there. So that's 26, and we divide both sides by 18. So the acceleration there is 1.4 meter per second square. Let us move on to part B. So the distance traveled by the particle in the first 4 seconds. So the distance S, that's what we want to find. But from SUVAT, we can deduce which formula to use. We want to find S. U, the initial velocity, is 0. V, we don't know. We have the acceleration, which is given. We calculated it. So it's 1.4 meter per second square. And we are also given the time, which is 4 seconds in the first 4 seconds. So we can use this formula from SUVAT. S is equal to UT plus a half AT squared. The initial velocity is 0, so this part of the equation would be 0. So S is equal to a half 1.4 times t squared, which is 4 squared. and that gives us 11.2 meters. So the distance is 11.2 meters. Now we want to work out the magnitude of the normal reaction between the particle and the table. So we want to resolve in the vertical direction. So part C, we resolve in the vertical direction there. It's horizontal. Okay, so in the vertical direction we would have R minus 18G. Weight is mass times gravity, so it's 18G, and that would equal to the mass, which is 18 kilograms, times the acceleration. So when we resolve in the vertical direction, the acceleration here would be 0. Hence R is equal to 18G. G here is 9.8, so we would have 18 times 9.8, and that gives us 176.4 newtons. So the magnitude of the normal reaction there is 176.4 newtons. So we have worked out the acceleration, that's part A, and then we have worked out the distance, which is 11.2 meters, and the normal reaction there is 176.4. Here ends question 2.